Hello dear students, hope you are doing fine and keeping yourself safe and healthy. I am Nabi Hassan, and today through this video I am going to teach a very important chapter in class 12 science and chemistry. The name of the chapter is Coordination Compound. Now when we start this chapter, the first thing you need to know is double salt and complex salt. Like, what is the difference between double salt and complex salt? Now I'll explain this with the help of examples so that you'll understand better. Okay. Now this compound is an example of double salt, whereas this is an example of complex salt. Now the difference between double salt and complex salt is, double salt, when you dissolve it in water, it will completely dissociate into simple ions. So if you dissolve this in water, ferrous sulfate will dissociate into ferrous ion and sulfate ion. Ammonium sulfate from here will dissociate into ammonium ion and sulfate ion. So the compound, the whole compound, you dissolve it in water, it will completely dissociate into simple ions. That means double salt, when dissolved in water, it will lose its identity. Whereas complex salt, if you dissolve it in water, it will remain unchanged. There will be no dissociation here. It will remain as it is. So complex salt will retain its identity in the solution. Okay? So next, let us say what is coordination compound. The next topic is co-ordination compound. So coordination compound are those compounds which contains coordinate bond. Coordinate bond. Like when you say ionic compound contains ionic bond, covalent compound contains covalent bond, coordination compound contains coordinate bond. Now coordinate bond is two center, two electron bond. In case of coordinate bond, two electrons are derived from the same atom or ion. Say you have this M bond L. Now here, for this bond, we need two electrons. Now both the electrons will come from L. So this bond is coordinate bond. So whichever compound contains coordinate bond is known as coordinate compound. So we can say, in the case of coordination compound, there will be a donor and an acceptor. So say M, L. Now L will donate two electrons to M and will form coordinate bond. So here L is donor, whereas M is acceptor. Donor in coordination compound is known as a ligand, whereas acceptor is known as central metal atom or ion. So next we'll study central metal atom or ion and a ligand. So in coordination compound, central metal atom or ion are those species which accepts 2 electrons to form coordinate bond. Let us take an example. So this is an example of coordination compound. Here Cl is donor, that means ligand, and will donate electron pair to Cu. So Cu, that is copper, is central metal ion. Now this central metal atom or ion, we can use atom or ion. Atom when the oxidation number used by copper is 0. Whereas if it is positive, we use ion. So here the oxidation number of copper will be 2 positive. That's why we use central metal ion. Next, let us see ligand. Ligands are ion or molecule which donates electron pair to form coordinate bond. Now ligands are classified based on different factors, so let us study the classification. So first, it's classified based on charge. So we know it can be either positive, negative or neutral. So if it is positive, say for example NO, positive. This is an example of positively charged ligand. So this is cationic ligand. If it is negatively charged, it is known as anionic ligand. Whereas if there is no charge, like NH3, if there is no charge, it is known as neutral ligand. So it's very simple. If the ligand carries positive charge, it's cationic ligand. If it carries negative charge, is anionic ligand. And if there is no charge, it's neutral ligand. Say F negative. So this ligand carries negative charge, so it will come under anionic ligand. H2O, aqua, is known as aqua. So you can see there is no charge, so this will come under neutral ligand. Say EN, ethane 1,2-diamide. So there is no charge, so this is also a neutral ligand. Next classification is based on number of donor atom. So based on number of donor atom, they are classified as unidentate, bidentate, tridentate, tetradentate, pentadentate and hexadentate. Now uni means 1, bi 2, tri 3, tetra 4. That means if you have one donor atom in the ligand is known as unidentate. If there are 2 donor atoms, the ligand is known as bidentate. If there are 3 donor atoms, it is known as tridentate. If there are 4, tetradentate. 5, pentadentate. 6, hexadentate. Let us see example. Cl negative. Now you can see there is only one atom. So we can say there is only one donor atom. So this is unidentate ligand. Say H2O. Now looking at this, you'll find there are 3 atoms. 2 hydrogen, 1 oxygen. Even though you can see 3 atoms, but there is only 1 donor atom, and that is oxygen. So this also will come under unidentate ligand. Now why only oxygen? Because hydrogen is not capable of donating a pair of electrons. More examples, NH3, you have 4 atoms here, 1 nitrogen, 3 hydrogen, but only nitrogen is capable of donating a pair of electrons to form coordinate bond. So that's why NH3 is also an example of unidentate ligand. Let us see the example of bidentate. Now you can see this is an example of bidentate ligand. The name of this ligand is ethane 1,2-diamine. So you can see there are many atoms here, but only the nitrogen atom is capable of donating a pair of electrons. So you can see there are 2 nitrogen atoms. So therefore there are 2 donor atoms. That's why it's bidentate. Now what about the carbon and hydrogen? We have already seen hydrogen is not capable of donating pair of electrons, so it will not be counted as donor atom. Same goes for carbon. Carbon is also not capable of donating a pair of electrons. So that's why carbon is also not considered as a donor atom. So in total we have only 2 donor atoms. That's why it's bidentate. Similarly, if in a ligand you see 3 donor atoms, it will be tridentate. If there are 4, tetradentate. If you see 5, it will be pentadentate, 6, hexadentate. So this is the classification based on number of donor atoms. Next, there are 2 special types of ligand. First, ambidentate. Ambidentate ligand. Now, ambidentate ligand, I'll explain with the help of an example. Say NCS. Now, this is a monodentate ligand. Here, both nitrogen and sulfur are capable of donating a pair of electrons, but only one will donate at a time. That means if sulfur acts as donor atom, nitrogen will not. And if nitrogen acts as donor atom, sulfur will not. That means ambidentate ligands are those ligands which have 2 types of donor atom, but only one atom is capable of donating the electron. I can give more examples like CN. Here, either nitrogen or carbon will act as donor atom. The next is chelating ligand. The chelating ligands are those ligands which forms a stable ring structure around the central metal atom or ion. Example is En, that is ethane 1,2-diamine. The structure of ethane 1,2-diamine is NH2, CH2, CH2, NH2. Now here you can see both the ends contains donor atom, nitrogen, nitrogen. Now when both the nitrogen donates a pair of electrons to form a coordinate bond with central metal ion, it will look like this. So this is copper, the metal ion, This nitrogen will donate electron and forms coordinate bond. Another nitrogen here donates electron to form coordinate bond. Now between these two nitrogen we have two carbon. So CH2, CH2. Now you can see this is a closed ring. This is a ring structure and this is quite stable. So chelating ligands are those ligands which forms a stable ring with the central metal atom. Okay? And this effect is known as chelating effect. Chelating effect. So, you can study more about the ligands, about their classification, types, and nature. You can study from the notes, okay? So, I'll start the next topic. That is co-ordination and tie-T. Now, coordination and tie-T is a combination of central metal atom and ion with the ligand. So, for example, Cu, NH3, all 4, 2 positive. Now here, the central metal ion along with a specified number of ligand which represents coordination number. So central metal ion along with a specified number of ligands enclosed inside a square bracket is known as coordination and tie-T. One more example. Now look at this example. Here K, potassium, is outside the square bracket. So this will not constitute the coordination and tie-T. The coordination and tie-T will be this part, that is FeCN all 6. And this will act as counter ion. Now the counter ion will neutralize the charge carried by the coordination and tie-T. And the counter ion, it can be either positive or negative depending on the charge carried by the coordination and tie-T. If the coordination and tie-T is positive, counter ion will be negative. If the coordination and tie-T is negative, counter ion will be positive. Is coordination number. So if we define coordination number, it is simply the number of donor atom which is directly linked to the central metal atom or ion. So I will start this coordination number in the next video, and before that I want you to go through the types of ligand, the nature of ligands, and the number of donor atom present in different types of ligand. That will be very important and will be necessary for calculating the coordination number. Thank you.